Okay, so we are going to set up and weld our Eagle hyphen reinforced belt. It's reinforced. You can see that there's some polyester threads in there, surrounded by polyurethane. So the idea of an overlap weld is that we don't want to just do a butt weld end to end, because we have to then drill the reinforcement back a little bit, and that weld is not as strong as the rest of the belt then. So what we want to do is we want to have the reinforcement all the way through the belt. So we're going to overlap weld it so that that reinforcement is all the way through. So it looks like a lot of belt to overlap weld. So that's where this thing comes in, and you'll see how that performs. So this is our overlap welder. Again, I already described that this is the Z block's the heater block. And this is what we're going to actually put the belt in to weld it. This is the temperature control box for the welder. So we'll plug the heater in. This is our thermocouple wire, so that's what's going to actually tell the temperature. And then we'll turn it on. Red indicator light comes on, and our heater control box is on. We're going to set this for 400 degrees, because that's what the instructions say to heat at. So we'll put it down to 400, press set, and we're good to go. So this will start heating up right now. This is at 67 degrees. At least that's what the thermocouple is saying it's at. And it should start heating up.
Brad, I know we overlap weld CAN cable on this as well.
Yep.
Do I set that to 400 as well? Is that a different temperature?
No, that would be 500 degrees for the polyester CAN cable.
So for the polyester, it needs a higher material to melt the material?
Correct.
All right.
And as I mentioned in a previous segment, the polyester, it needs a higher temperature, it takes a little more to start melting, but when it does, it goes quick. So you have to be on top of it. So we got to wait till this heats up to 400 degrees. So while that's heating up, I'm going to go ahead and start getting the clamps set up and get the material set in here. So these are our hold down clamps. This is what's going to actually hold the material in our dies. It's tough to see, but this is stamped 3/8 hyphen. That's what this belt is, a 3/8 round hyphen belt. So when we put our material in, there's a natural curve to it. We don't want that natural curve sticking out like this or back like this, because when you clamp it down, I don't know if you can see it, but it kind of sticks out. It's not very clean, it's not very neat. Plus we want the curve to be facing the same way either way so that it doesn't twist the belt. So I'm going to put the curve down.
Do you cut in the previous trim that we've done, we cut the ends of the belt square. Do we cut the end of this belt square as well?
So absolutely. So we have a set of cutters like we do with all the other kits, and we want to make sure that that's perfectly square. So we don't want to twist it this way, we don't want to twist it this way. We're going to just cut a nice square cut. We're going to go ahead and put this piece in. Now, you can't see it on this end, so I didn't mention it from the camera angle, but on this end you can see that I have about between a 16th and an 1/8 inch of that belt sticking out the end. The reason being is not only do we want to melt the sides of the belt together, we want the ends to be melted so that they stick together as well. That's why this heater block is shaped like a Z. So we want that end sticking out to come in contact with that Z of the heater block on this end. We want this end sticking out on the back side of that Z. So we're all set up, we're clamped in place. We just need to wait for the temperature to come up. So we're up to temperature, we'll go ahead and start welding. So you turn the Z block in to the center, this slides back and forth. There's a pin on the back that you have to pull out to unlock. So you can slide that down and then let go of the pin, and that locks it down. We're going to need to release that pin later. What's nice is this slides freely so that as you bring the clamps together, material clamps together, that Z block slides with it. Now, as you're tightening this, we want to let the melt rate dictate just how tight and how fast we're bringing it together. I don't want to tighten this up really, really tight as it goes, because we're going to squeeze all that melted material out, and we don't necessarily want to do that. We want that melted material in there to bond to each other when we bring the two sides together. So if you'll notice, I'm just using a very, very, very light finger pressure to screw that in. So I'm letting the melt rate dictate just how quickly that melts.
If I go out in the field to show a customer how to do this, would you suggest that I practice this several times before I start?
Absolutely. Not even just the feel of this, but when these come together and it's time to actually put the belt ends together, it's like a magic trick. I mean, you need to be fast, and you need to have a good grasp of all the steps of what you're doing to be able to do it quickly. And you'll see exactly what I mean when we get to that point. But like I say, I always say it's like a sleight of hand magic trick. When you release, when you get this all melted and it's ready to be put together, you have 3 to 5 seconds to get it done to form a proper weld, preferably under 3 seconds. And inevitably, when I have people watching this and they watch me do it, they say, "Oh, that's easy. I can do that, no problem." And then they are nothing but fumble fingers when it comes time to actually do it, because you got to remember the steps and you have to be fast. So absolutely, practice is key. So it's starting to tighten up, which means that this block is pressing up against the heater block, which is in turn pressing up against the back block, which means that half of each belt has been melted away.
And the urethane belt that you're actually welding there is significantly easier to do than
Can cable.
Okay.
Oh my, yes. Yep, absolutely. So now that I've got it all closed up, I'm going to give it about 20 to 30 second dwell time for this particular size belt. So I'm watching the clock here.
Are you guessing that, or is that on the instructions?
That's a lot of experience, and I believe the instructions also do have a time chart for you.
Okay.
So this red handle, I'm going to keep force in on this red handle to keep that clamped, and I'm going to move my wing nut out of the way. I'm at 30 seconds. I'm going to back off pressure, pull the pin, get that out of the way, put that together. You have to be fast. So that is exactly why I say, please, please, please practice. So I got a little bit of polyurethane on my blade. I'm going to go ahead and clean said blade, because we don't want to leave any polyurethane residue on there. It's hot. Please don't burn yourself. If you're only doing one weld, go ahead and shut the heater off so that starts cooling off. We were going to leave it in the clamp for 3 minutes. Once we take it out of the clamps, we're going to want to give it a half hour, well, 27 minutes, so total of half hour cooling down time. We're also going to have to cut all that flash off, so we're going to let this sit for 3 minutes. So I'm going to run through in slow motion how to actually get the blade out of the way and get the belt put together quickly. Now I'm going to do it in slow motion, but this should really be done in under 3 seconds. 3 to 5 seconds we say, but preferably under 3 seconds. First thing you're going to do is you're going to put your hand on this red handle and keep force in that direction, because we want to keep the belt on the heater while we release this wing nut. So we want to get that out of the way. I'm going to very slowly release pressure. I'm going to pull this pin. I'm going to swivel this out of the way, and then I'm going to use my hand to bring that back together. While I'm holding that together, I'm going to bring this wing nut back into place. And I'm going to tighten it up as tight as I possibly can. Again, that process should be done in about 3 seconds or less if you can. Okay, we have let that belt sit for 3 minutes minimum inside the clamp, so we're going to go ahead and pull it out and cut our flash off. So the first thing you're going to want to do, one, is avoid the blade if it's still hot because you're still doing other welds. We're going to loosen the clamps up first. Then we can loosen this wing nut up. Then we can back that off and separate it. So now you can see I've pulled the belt out. It is essentially melted half of each belt away and then stuck it back together. So I'm going to go ahead and cut all this flashing off, which can be a bit time consuming, but that's all right because we want it right. When you get really skilled at this and you're doing training, you can impress people by cutting it off all in one piece. But I'm not that concerned about it today.
Or skillful.
Or skillful. No, I can do it in one piece. But thank you for the peanut gallery comment. Now some shops will then take this, if it's not on the machine yet, and take it to a little grinding wheel or something and linish it smooth, just so you don't hear a thump as it comes through the pulley. But I've cut that all off to the best of my ability with these cutters, and you can see the seam where it's joined together. So the nice thing is that reinforcement is all the way through that now. So what I'm going to do is cut this so that you can see the two reinforcements next to each other.
Is that weld a weak point in the belt?
Absolutely not. Because the reinforcement is all the way through it, it's now as strong as the rest of the belt. So I'm going to go ahead and cut this so you can see what the inside looks like. And you can see that it's double the thickness of reinforcement on there now. So we know the reinforcement is all the way through there. And that is it for welding our Hyphen Eagle belt.